Okay, let's start. Do you have any questions? All right. We still have one more class. All right, on Monday. Monday will be the last day of class, so we still have one more lecture. All right. So I thought that this week is the last week, but we still have one more class next Monday. Okay. All right. So let's kind of continue with where we were last time. So we were discussing, right, exchange rate model. So, okay. Maybe, right, let us just go straight to, so, right, I wanted to, convey the message, right, that you kind of start out with something like a domestic, right, physical probability, and then you can translate to, right, domestic risk neutral. And the story there, right, is not trivial, okay? Because for two reasons, right? The first part is about the two Brownian motions, right? Or rather three, right? Like this, right? The ST is, let's say, mu ST dt plus sigma 1, right? ST dw1t, right? dqt is, let's say, gamma, and then sigma 2, right? Rho, so qt here, rho dw1 plus 1 minus rho square 2, right? So you have, you need more than one Brownian motions, right? Because you have two assets. Also, right, it's not quite easy to recognize if you don't know what you're looking for. But this is also a Brownian motion, right? Even when rho is a random process, actually, okay? It's pretty standard. You can just figure it out. But this is also a Brownian motion. The reason why we write like this, right, in a more complex form, is because we want to, right, denote the idea that the correlation, right, between the return, right, of the exchange rate and the stock, right, is rho. Okay. But if you just look at the exchange rate by itself, then you can just collapse this to like another Brownian motion. Why? Because it's easier, right? Because it's just really a geometric Brownian motion process with volatility sigma 2. Okay. Anyway, right? Then the conversion, right, is physical, right? The conversion, right, requires us to recognize that the stock is pretty standard, right? But the exchange rate, right, is rather, I would say, new, right? In the sense that the the return, right? The rate of return for the exchange rate is not R, okay, but R minus RF. The reason, right, is because this is the price of 1 unit of currency of, of 1 unit of foreign currency, right? And, $1 bill, right? If it's sitting in your pocket, sorry, €1 bill, right? If it's sitting in your pocket, it's not earning any interest, right? It's not earning any interest of its denomination. Therefore, right, it will lose out, right? This part. And so the message here is, again, you should kind of look at this as the exchange rate. You definitely should look at it as exchange rate in the context. But in terms of pricing, right? In terms of pricing, because we will have, or we do have, right, options on the exchange rate. In terms of pricing, right, Q behaves exactly like the price, right, of a dividend paying stock, right? software asset, whatever, with rate RF. All right. So I want to say this because we did not have time to cover dividend rate in this dividend paying asset in this class, but we discussed this anyway, and I hope, right, you can go back and read on this for yourself and see that the logic is exactly the same. Why? Right? Because you can really see, right, that in fact, right, I mean, notice this is the price, right, of a dividend paying stock. When the stock pays dividend, it decreases in price because that part goes out as cash to the stockholder. Of course, the story goes on as like sometimes they automatically reinvest into the stock for you, etc. But so there is another process which is on the other side, right? We have which we call the foreign money market, right? Which is just the one that earns foreign interest rate, right? So notice when we do this, right? Of course, we are not assuming any stochastic model, but when we do this, right, this is in the foreign currency, right? This is in foreign currency. Like, euro, whatever, right? So there is another one, right, that corresponds to this, which is the, we don't want to invent another name, but basically the value, right, of the foreign currency, the value of the foreign money market, all right? So this is in, right? This is in, but this is the foreign money market, right? All right. So this is the value of the foreign money market in US denomination, right? So this guy right here, whatever you want to call it, right? You can call it X, for example, right? It's exactly the, value, right, of foreign money market. In US dollars, right? So if you do this, then this guy will, right, because it earns the interest rate, right? And then you translate it back to the US dollars. Basically, you can check that, that it works out like this. Okay. So again, the math, I don't want you to think that this is just conceptual. I mean, of course it's conceptual, but the math exactly works out like this as well. In other words, if this is true, then you can apply Ito's formula, right? In fact, it's just like a regular calculus. You don't need Ito's, but yeah, you have this, so you kind of need Ito's formula. But you can apply Ito's formula to get exactly that, right? It works out exactly like that. Okay, but the concept, right, is just very simple. If you earn back the foreign interest rate, then of course, right, you don't lose out. Okay, so there's that kind of subtlety that you want to keep in mind when you do this. And then, right, we have a new kind of product, right, which we don't usually have in the usual option pricing, right? Call option or put option, whatever you want, on the exchange rate itself. Why this is new? It's new because, right, this is like an option on a dividend paying stock, right? So the usual Black-Scholes formula does not apply to it, but that's just dramatic, right? Because I show you that it's really just a small trick, right, to reapply literally. So first of all, you have to remember that in terms of pricing is the same formula, okay? This may be surprising to some folks because they might think, right, again, I can see the logic in quote here, that because this is R minus RF, you would do R minus RF here, right? Now, just to check, why would that be wrong? Or would that not make sense? Right, some folks might do this, or am I thinking too much? None of you guys would think about this. Why would this be wrong? You understand the question? This is right, a call option on the exchange rate in the future with strike K, right? Like, you can buy, I don't know, one, right, euro with K dollars, right, in the future. That's all it says. We want to find, right, the price of that option right now. So this is the pricing formula, straightforwardly enough, but someone might want to do that. Why not? Why would that not be correct? Okay, so not as simple, right? Well, so the reason, right, is you have to, actually the reason is you just have to know what the pricing formula does, okay? In other words, sometimes you take this as, a truth, right, or whatever, that, you don't really question. So when situation change, you don't know if something should change or not. So the thing is, right, this is just really time value of money, right? You bringing the future payment back to the present. And we are operating, right, in the domestic market. So you got to use the domestic interest rate to bring it back to the present because everything here is in dollars. Okay. The risk neutral part is about, right, the point of view that, okay, if there's any asset that acts like a martingale, right, that we are indifferent in terms of future and past present value, right, then the discounted, right, risk neutral will bring it back to the present price. So it's like a consistent fair pricing framework. Doing this makes no sense because you're just matching symbols. Because here you're saying you're discounting, right, the future value with this rate. Well, this is not a rate anywhere, right? Not a rate in the US market, not a rate in the foreign market, nowhere, right? So this is just you matching symbols without understanding the concept. Understand? So that's why it won't work. All right. So again, this is the right formula, right? And to work out this formula, right, we do the math, which is matching symbol kind of, but right, once we write down the right pricing formula, then we can just match the symbol. Okay. But of course, right, here, from here to here is mathematics. It has no meaning in terms of finance, right? We just kind of multiply and divide so that now, right, we line things up in Black-Scholes, right? So it's going to be basically, right, E to minus RF, right? Q0, right? ND plus minus K E to minus R minus RF, right? T ND minus, right? But now, right, the plus and minus also involves R minus RF, right? Right, like that.
Can I ask a quick question?
Go for it.
So you included e to the minus RF outside.
I miss it. I miss a T. Is that what you're saying?
Yeah, thank you.
Yeah, thank you for that. I wasn't paying attention. Thank you, Billy. I don't mean that for that to be a mystery. I just forgot. Yep. All right, cool. All right, all good. All right, so that should settle, right? Everything in the domestic market. So that, right, that's just really the beginning. We're not here to discuss the domestic market. We're here to wonder, right, what's the story on the other side of the world? Meaning, right, we want, first of all, right, the other exchange rate, right, the price of the US dollar, right, in terms of euro, for example. And then we want to know, right, the price of Apple, right, or whatever stock you want in euro. Okay. So obviously, right, you can really operate on this from the domestic point of view, But you will see, right? Right, you can work on these under P tilde theoretically. But I'll tell you two things, right? First of all, is the math is not going to be pretty because of the division and etc. Right, as you saw from before, which is a sign that you're not really using the right framework, because anytime the math is not pretty, something is not quite in place. But the second actually is also awkward in the sense that the unit of this, right, unit wise, this is in euro, and P tilde applies to things in dollars. So you could mathematically, but financially, it's also a little bit questionable, right? What are you doing? So may not, right? I just do may not. There's a way to make it work, and in fact, right? But may not make sense financially. In terms of unit, right? I'll just put it like that. I mean, the thing about all these things is it's a little bit confusing. You could, I'm not saying you can't, but you have to watch out for what kind of unit you're discussing, and So the point I want to sell is that there should be another, right, which we kind of hinted at last time, foreign risk neutral probability, right? That is suitable to discuss this guy. Okay. So again, let's repeat our question, right? Questions. So what's the dynamic, right, of these guys under the foreign risk neutral probability, right? And also, what is P tilde F, right? And its relation to P tilde, right? Finally, what is the relation between pricing under P tilde F and pricing under P tilde? All right, because some of these products may be related. For example, a call option on an exchange rate on one side intuitively is connected with a put option on the exchange rate on the other side. Okay, like a call option on the euro dollar exchange rate is somewhat in a way will be equivalent to a put option on the, I don't know what I said before already, US euro exchange rate, whatever, so we'll see that, right? But what kind of connection can we put there? All right. And again, this can be quite confusing if you don't know what you're doing or you don't have a good conceptual framework in mind. So I just want you to first see the intuition. The first intuition you should have is this guy, right, must have this kind of drift, this kind of rate of return. Why? Because it's just the other guy, right? The reverse version of it. So here, right, you could do this. Also, the stock should have the rate of return as the foreign risk-free rate. This much is, let me say, I don't want to say easy, but you can expect that. Also, as we said before, right, what's challenging is the volatility terms, right? And then maybe what kind of prime motion, right? You might have W tilde 1F and then W tilde 2F, for example, right? But what are they? And then, right, same thing here, right? So that's the question we were asking. And so the clues, right? The clues to think. So this is the valid question to ask, a crucial question to ask. The clues, right, to figuring these things out, okay, are the following. First of all, right, you know that, and by the way, right, these are Newbry motions, okay? These are Newbry motions. These are not the same as the Bry motion under the domestic risk neutral probability, All right, they have an F next to that. So the clue is like this, right? You know that basically, right, the discounted, right, stock price must be a martingale under the foreign risk neutral probability. Now, this in the same way, now this might feel awkward to say it out loud, but in a similar way, the other exchange rate, if you discount it at the right rate, is also a martingale. Okay. Now, if you feel this is awkward, this actually can be easily translated like this: discounted, right? But then this is this. So this is nothing but the US money market in the unit of euro. All right. So put it like this is very, very natural, right? The US money market in the euro, right, denomination is counted. Sorry, I missed a T here, right? Is counted under a euro rate must be a martingale under the euro risk neutral probability. Okay. Why would this be important knowledge? The reason is, right, you can connect it with the exponential structure. Right? I kind of talked about this last time. What does that mean? What that means is Ito's formula tells you something very basic like this. If you have something like this, right? So whatever boundary motion, whatever mu sigma, as long as it's constant, then this must be an exponential structure like this. Right? That's Ito's formula for you from day one. So that's where calculus enters. So this and this are corresponding structures, right? One implies the other. So, right, so here the discounted with rate mu of xt will make it a martingale. So in other words, right, this guy right here is a martingale. All right. So when you do e to minus mu t, you just kill this part. So you leave out a martingale. Why would this be important? The reason is, right, you can do the math here, like we talked about last time, right, and get some idea about the exponential structure of this guy, right? Because 1 over an exponential is still an exponential, right? The division of two exponentials is still an exponential that we talked about last time. Yes. So therefore, right, the exponential structure gives you some clue. For example, right, we know that qt is q0 e to the let me remember, r minus rf, right? Minus 1/2 sigma square, right, times t plus sigma w tilde, let's say 3, right, like that. Okay, that's wt, great, right? This is of course under p tilde, under the domestic risk neutral probability. So if you do 1 over q, right, then you got 1 over q0, and then you flip it, this thing, so you got rf minus r plus 1/2 sigma square t, right, like this, and then minus, sorry, this is sigma 2, right? Okay, so you flip this, so you already convert this, right, into a unit of the foreign money market, except this guy, right, is still the prime motion under p tilde. All right, so now, right, you want to convert this, you want to convert this point of view to under p tilde f. All right, but you're almost there, right? So I just want to show you what you use the exponential structure on. The next thing, right, is of course you want to convert, you know, w tilde I, right, let's say, to W tilde IF, right? You want to convert the Brownian motion under the domestic risk neutral probability to Brownian motion under the foreign risk neutral probability, right? Their counterpart. Now, you don't know how to do this yet because this is exactly the change of numeraire theory, which we'll talk about very soon. But one clue is this, right? And the only clue, it's a very strong clue actually, is the only way that you can change one Brownian motion to another that preserves the equivalence of probability is by changing drift. Okay. So what I mean is this, that you may not know how exactly things are changed, but you can be guaranteed that this is what happens. No other way, meaning there's no other relation that can hold between these two Brownian motions. Okay, I mean, things can get more complicated in the sense that this might be a function of t, right? Sorry, this might be a function of t. That's it. But in terms of changing probability measures, if you want to preserve equivalency, then a new Brownian motion can only be related to an old Brownian motion through a drift change. That's actually the more general message of Kirsanov. All right. So the job of like change of numeraire or change of measure kernel is to tell you exactly what this guy is. That's all. All right. Now, why is this enlightening, or why would that be a good knowledge if without knowing theta I? Why it would be good is this, because you know that, right? To move this to a W tilde F, what can you change? All you can change is to add and subtract a drift term. So what it tells you is, right, notice, right? This is like detective thinking. You know what can be changed and what cannot be changed. That's what I'm trying to show you, right? Without doing much work. Because if you don't know what you're doing, you will do a lot of hard work without getting any result. Basically, what you know is that it doesn't matter what W tilde 3F is. The term in front of this must always be minus sigma 2. You will never be able to change this term, the minus sigma 2. That's what I'm trying to say. You understand? Because, right, how these guys are related is through the drift. You will never be able to touch the volatility by adding, subtracting the drift term, because this is T, which means it will get absorbed into here. And coupled with the fact that you know it's got to be a martingale, then you know that whatever it is, you even know what the change in the drift is, but we'll get there later. You know that it must be exactly this. Sorry. You know that it must line up like this, no other way. So sorry, I missed it too. That, right? You don't need people to tell you what this is. It's nice to know, but because you know that it must line up to be a martingale, and the only way to change Brownian motion is like this. This is the formula for the other exchange rate. No other way. Do you understand? Question. This is quite important, right? And this is as simple as I can make it. All right. Meaning, right? Okay. We'll talk about the meaning later. Is this okay? Any of this part of the reasoning that makes no sense? That does not make sense. All right. So let us look at the stock there, right? So the stock is similar, right? But a little bit more messy because the stock in the other denomination will be this, right? So it will be this, and then you got the exponential. Let me see, right? It will be RF here, and then plus, right? 1/2 sigma 2 square minus sigma 1 square, right? And this whole thing times t. And then you got sigma 1, right? Plus sigma 1, W tilde 1, right? And then you got minus, right? Sigma 2, and then you got rho, W tilde 1, plus 1 minus rho square, W tilde 2. Right? So that's the stock. Okay, so far? All right. So now, right, this is still under P tilde that we're looking at because we didn't change ground motion yet. Right? And again, right, let's see how we apply our knowledge, right? Our clue. First of all, we know that, right? So let's call this S0F, right? Because that's just that. We know that this term, right, whatever it is, must be just RF minus 1/2 the volatility of the stock under the foreign risk neutral probability. But that might be a little bit tricky, so we'll figure that out later. What else do we know, right? What we know is that this guy, when it moved to W tilde F, right, 1, all it can do is like I said, right, it can only change by drift. So the term in front of it cannot change. The volatility term in front of it. So in other words, so we do RF, right? And then minus 1/2, I will put a question mark here, T, all right? And then you must have sigma 1 minus sigma 2 rho times the foreign prime motion. And then you must have this. Like that. Okay, so far? So maybe let us call this sigma F, right? Meaning the sigma of the stock. If you want to call sigma 3, it's up to you. So question, right? What is sigma F? Which is the volatility, right, of SF. How do you answer this? Answer, sigma F square will be sigma 1 minus sigma 2 rho square plus sigma 2 square root of 1 minus rho square. Whatever that is. Okay. Meaning, right, it's going to be the combination of the variance of these two terms. Whatever that is, you take the square root, or you just take the square and you tuck it there. In other words, right, the answer to our question will be this. dQf will be RF minus R QFT dt minus sigma 2 QFT dW tilde 3, right? We'll get there. All right, we'll get there. the point, right? The point I want to make here is, which is the amazing point I want to make is, we can do this without knowing the theta. That's the amazing thing. All right. Because again, we know how this guy must behave. So it's amazing we don't need theta to operate there. But yes, we would say what theta is, and you see that everything checks out. Like the thing I'm doing here will be consistent with what thetas are. Or in fact, you can reverse engineer what I'm trying to say here and know what theta is. But the point I want to make is, right, I'm working on these bypassing the whole framework of change of measure because it's messy, just working on the fact that this is a martingale. So I'm working on martingale theory and you know, bypass the tedious calculation. So these are under P2F. Is this okay? Any question about these results, or more importantly, the argument? So to recap, right? Remember last time I was telling you, right, from another point of view, it's important for you to know what the volatility, right, of the exchange rate, the other exchange rate, QF, and right, the stock listed under the other unit currency, right? And it's not easy to get the hold of this intuition if you don't haven't seen the result before. But what it's telling us is, right, that the volatility of the two exchange rates are essentially similar or the same. Now, of course, right, this is a minus, but right, when you say volatility of the other exchange rate, volatility has no sign, right? Because, you know, minus of Brownian motion is still Brownian motion. So this is just, we write this just to kind of, you know, stay with the math, right? Because we have a very specific meaning for WTO3. But in terms of dynamics, right, you won't be able to tell difference if it's a minus or plus. You know, you just change it to a different Brownian motion, right? So volatility of the exchange rate here is also sigma 2, right? So the exchange rate, one way or another, has the same volatility, which might sound a little bit. Oh yeah, times row. Thank you. Thank you. Yep. Thank you. Yep. Right, which might sound a little bit baffling, but it's not, right? Because like I said last time, right, if the euro dollar, right, exchange rate is volatile, the dollar euro exchange is also equally volatile, right? You don't expect one to be more volatile than the other, right? On the other hand, the volatility of the stock gets changed in a very complex way. Or, you know, I don't want to say very complex, but more complex, right, than just that. In fact, the volatility of the stock cannot stay the same, right? It will get mixed with the volatility of the exchange rate, but also take into account the correlation. So notice, right, if rho equals to 0, if there's no correlation between the returns of the stock and the exchange rate, then what do you expect the volatility of the stock in the other exchange is? Well, isn't that just a straightforward adding of the two variance? Of course, that's what independence tells us. Okay, I hope this clears things up a little bit. But in general, right, if you have correlation, then the new volatility will change in this way. Okay, again, right, this is a complexity of the model that I hope you appreciate. So we cannot just guess and eyeball that kind of thing, right? This is where the math helps us say things in a concrete way. Any question? Okay. So either the lecture is very easy and you get everything, or the lecture is very hard and you are completely lost. You have no idea what question to ask. Okay. Anyway, so let us mention some products, right? Well, obviously, right? Now, so this tells us the consistency of the products, right, with the under the domestic market. But obviously, right, you can start out with this market, right? The European people obviously don't care about our market, to the US market to begin with. They could just start out modeling, right? Their model like this. So for them, this is domestic, right? And like this, right? Where, I don't know, they would call this some number and they would call this another number, for example, right? So anyway, so the point is that then, right, they could have some product like this, right? First of all, they could have just a call option, no? Under for the Apple stock, right? Listed under their denomination. They could have also a call option or put option, well, we'll look at that later, for the US dollar, right? Listed under their currency. All right. And of course, all of these are really just Black-Scholes. Okay. Now, actually, it'll be very, very interesting for you to think about actually this. Right, so let's call this V1 and this is V2. Right, obviously, right, the common formula is still this, right? VI is E tilde F, right, of E to the minus RF T VIT, right, like that. Now, the pricing of this is very easy, even though you still have to watch out for the fact that this is still a dividend paying stock, right? Under the foreign risk neutral probability. Oh, sorry. I missed an F here, right? Yeah. So this actually is almost the same formula as what we did before in the domestic risk neutral probability. But this, right, because of this, might be a little bit challenging, no? How would you figure out the call option using Black-Scholes? It's got to be possible, right? You're not gonna just recalculate everything. Okay, so I think the homework of this week will ask you to explore that or something like that. But right, notice that you have to be able to price this very quickly. Okay, no question. But how do you do that? So being flexible with Black-Scholes, right? Not just, okay, you give me this, I give you that. That's it. If I change the model, I don't know what to do, right? So you should be able to figure this out, right? It's concretely, analytically. Okay, so I'll just put that there as a question for you to think about. Which we won't discuss right now. But what I want to, right, discuss next is then the connection. Now back to the, the connection, right, back to the domestic risk neutral probability. Okay. So now, right, so connection. In other words, right, what I want to say is you can just isolate the foreign market and just work under the foreign risk neutral probability itself. Never worry about the US side. But right, the point here is we want to see how both sides correlate to each other. So connection between P tilde F and P tilde. All right. So this is about change of numeraire framework. Proper. All right. So for this, right, let us present a very general one like this. Okay. So the context, right, the hypothesis is this. Suppose, right, I have, let me call this, I don't know. Let me have M, right? MT is a P tilde martingale. NT is also a P tilde martingale with two conditions. Do I want two or one condition? It doesn't really matter. I'll tell you both. I want NT to be, is it positive or non-negative? It should be non-negative, but it could be it should be positive in some way. All right. So what should you think about when in this, right? By the way, this P tilde can be actually any P. All right. So in fact, let me just call it P, some martingale under P, right? So the point of view is this is a very general framework. It can apply to anything. The challenge for you is to know which one is which under what framework. All right. So for example, for us, right, P here is of course P tilde, the domestic risk neutral probability. M will be the discounted stock price. N will be the foreign risk, foreign market. N will be the discounted foreign money market. All right, because there are three things in here, so I'll just spell it out for you. Discounted, right? Foreign money market. All right. So this is why sometimes you want to keep the symbol compact and not fold it out too much, because if you write everything out, you have like 3 or 4 symbols, right? But notice, first of all, I want to tell you this, that okay, let me tell you, and then I'll tell you the confusion that can usually happen when you do this kind of thing. So now, what do I want, right? So basically, what I want is something like, the process that you want is something like this. You denote it like this: M superscript n of t to be mt over nt. All right. So this is exactly what we mean by change of numeraire. What we mean is, basically, right, like the price of M, right, denoted in the unit of N. Okay. So that's the process. Now, what do we want? we want, right, a change of measure. So we want to have P to Pn. All right, how? So Pn of anything, sorry, so expectation under Pn of anything, right, we'll just call it En, will be E, the original probability of, so what's the kernel, right? Anyone care to guess what the kernel is? What the change of measure kernel is? So here, right, maybe let us fix a time, right? Let us fix a horizon with T. No, M actually is not the kernel. Here's a clue. I never really say what sign M can have. Right? A martingale can be negative, right? Like a Brownian motion. So that's not. This guy right here will be the kernel, except you have to be careful. You have to divide by N0. Why? Because, right, remember, a change of measure kernel needs two things, right? Expectation of the change of measure kernel must be 1, and that change of measure kernel must be non-negative. So here, right, I could have make it so that, you know, instead of calling this the numeraire, I can call this the numeraire itself. You know, there are many things you can do here. So here I just let the unit float, right? I don't normalize. I normalize in the change of measure. Is that okay? So here I use the so here, obviously, right here, let me say this. N is a numeraire, right? Right here, actually. Because of this, N is called the numeraire. A numeraire. Numeraire here, I don't know, is obviously probably a French word, you know, means unit, that kind of thing, right? So you change the unit, right? So it's a numeraire. So you use the numeraire itself as the change of measure kernel, except that you got to normalize, right? If it's already normalized, you're fine. But if not, then you need to normalize. Is that okay? If N0 is already equal to 1, then nothing. So that's the definition, right? What's the catch or what's the kicker? The catch is this, right? MNT is a martingale under Pn if, I guess you can do both. M is a martingale under Pp. Right, so I don't need this to be a martingale originally, right? M is just any process, so I don't need that. Here's what I need so that, you know, I can change measure. But the result is that if I start out with a martingale and I change the numeraire, then the changed numeraire process is a martingale under the new measure. Got it? Okay. So, you know, what's the proof? Use the conditional change of measure kernel result. Right? So, okay, so, right, basically this is my ZT, right? You remember what the change of measure kernel result is? Or, so to remind you, right, suppose we remember before, right, we said something like this. If E tilde, right, of X is E of ZT times X, right? Then what is E tilde of X conditional FT? What is the result? I mean, well, it should be this, right? But we know Z is a martingale, so. Right? So what we got here? We want to get this to be a martingale, right? So you mean in the lecture, in the context? In the ones above? Or what are you asking? What do you mean by use? So here, right? Obviously, what is this? This is okay. Maybe we'll pause the proof a little bit, right? We'll complete the proof. Yeah. So here. So here, right? Okay, fine. So I'll prove it later. Where have we seen change of numerator? So I claim that you have seen it without calling it change of numerator. Okay. Let me show you. Remember, when you start out from physical P tilde, right, to risk neutral P, right? Sorry, P tilde. No, that's not quite, right? Yeah, almost, but sorry, risk neutral P, right, to physical P to risk neutral P tilde. What's the statement? The statement is e to the minus RT ST is a martingale, right, under P tilde, right? Well, you may not think much about it, but this is actually a change of numerator. What's NT? All right. So in fact, right, when you move from physical to risk neutral probability, you are saying, which is what? This is our domestic money market. So when you change from physical to risk neutral probability, you are saying that, right, instead of measuring the stock price by itself, I will measure the stock price by the unit domestic money market. Okay. So the whole conversion of physical to risk neutral already is a change of numerator. That's my point. We just never really say it that way, but it is. Okay. Now, the second one, which is more significant, right, in this lecture, and that's what Fatima was trying to write, is, right, now P tilde to P tilde F. What is it? So, right, we have things like, so of what's NT here? NT here would be the foreign money market times QT. Okay. So what's the result? The result is, right, any, right, suppose you start out with eta minus RT ST, right, is a P tilde martingale, then the result says that, right, if you, oh, sorry, NT itself is a martingale, right, so it should be eta minus RT. Sorry. Like this, right? So the result says that, right, if you divide this, right, so eta minus RT ST divided by eta minus RT MFT QT. Yeah, I'll get to that a little bit, right? So this will be, right, ST divided by QT, right? And then eta minus RFT, which is eta minus RFT SFT, right? This should be is a martingale under P tilde F. Okay. Another one, right? One, right, is a P tilde martingale, right? Obviously. Therefore, hold on. So 1 divided by, right, I'm trying to get to the 1 over QT here, but I think I'm running into some trouble. Oh, you know what? Yeah, it's true, right? E to RT, no, it's true. And then, right, E to minus RFT, 1 over QT, which is exactly E to the R minus RFT, QFT is a martingale under P tilde F. Okay. So exactly, right? These are the two processes that we show. We say that they must be martingale under P tilde F. What does that mean? What is P tilde F? P tilde F of any random variable will be, sorry, expectation, right? Expectation of X, right? What's the change of measure kernel? It will be this divided by N0. So E to minus RT, right? MFT QT divided by, right, Q0. Because, right, at time 0, this is 1, only this is Q0. So that's that. All right. So number 2 is the most important. That's in our context. I think Fatime was pointing out something here. I'll look at that a little bit. But are we okay with 2 here? Any question about 2? In terms of what we mean by the numeraire. So, right, the most important thing is to identify what your numeraire is. And the catch is, right, it's got to be a martingale. Or, you know, so it depends on how you want to do it. In some contexts, you can define the numeraire. Where was it? You can define numeraire so that you could do something like this. You could say this is a P martingale. You could do that. Then you have to include the discounted, right? You have to include the discounting inside the conversion. So it gets a little bit, you know, tedious in some way. So here I decide to just make the numerator a martingale, all right, which is different from the way the notes is presented. So it's up to you. So the difference is only that, you know, that whether you include a discount term or not in the martingale into the numerator, but it's up to you. Any question? All right, so I think Fatime was complaining about this part, right? This is not a martingale, is that what you're saying? Let me think about this, all right? Let me think about this. You're right, but I'm very sure, right, that the change from physical to risk neutral exactly is like using the money market as the numerator. But yeah, I think it really is about, you know, how you define numerator. And I think I might have some inconsistency here, but the concept is there, all right? The concept is there. Maybe I messed up with what I want to be, you know, maybe here, right? I think unconsciously I was trying to use the fact that e to minus rt nt is a martingale rather than nt itself is a martingale, all right? So maybe that's why. Now, obviously, right? So like I said, I think there's something there that I'm not being consistent, but this is really a change of, yeah. But here, right, I really include this into the numerator itself is, yeah, I apologize for that. But all right, so I just hope that you understand the idea, right? The idea is you must have some martingale that's non-negative as your denomination. And when you divide by that martingale, all right, then if you start out with a martingale, then you will stay martingale under the new probability. All right, that's the message. And so together with all of this, right, to answer your question, this will allow you to figure out what the theta I is. Why? Because the theta I is also included in the structure of the Q. Okay, that's where it comes from. So basically, right, the Q will tell you what the drift term is for the theta I, but we're not gonna write it down completely if we don't need to. All right, so I understand that there are quite a few things here for you to digest, but you know, do ask me questions if you catch something that is not clear. So maybe let us move to some applications, all right? Maybe this is, we'll see more example, we'll clear things up for you. The first one, right, is an interview question that I told you about a long time ago. So the interview question was, right, in the Black-Scholes formula, you got S0, right? Sorry, if you got VT is ST minus K plus, then V0 is S0 ND plus minus K e to minus RT ND minus, right? Then they ask you the meaning, right, of D plus minus. And so, right, we said, right, remember that V0 by risk neutral pricing is like this, which is equal to this right, which is equal to right? So it's pretty easy to see that ND minus, right, is this guy, which is, so ND minus will be the risk neutral probability that you end up in the money. How about ND plus? It's clear that, right, this whole thing is ND plus. So how do you arrange it? How you arrange it, right, is you clearly have this, right? Or rather, right, let me divide S0 on the other side. Okay. Do you see what this is? So that's like your X divided by S0. This is a martingale under E tilde. So this is just E of S of this, which is the probability so that's what it is. It's the probability that you end up in the money, but under the probability, right, using the stock itself as numerator. That's what it is. Understand? Question. All right. Second, let's take a look at the call option on the exchange rate. Well, V0 here, right, would be E to minus RT, right, QT minus K plus, no problem. But let's work on this formula. First of all, the plus function, if you factor out a constant, a positive constant, is still linear under that operation. So you can factor out QT. Okay. Now this looks awfully tempting, right? In what sense? Well, we can do E to the R F T QT, right? And then is counted, right? Let me try to think. Yeah, this. Right? And then discounted. And then let me just do this for now. And sorry, let me do Q0, right? And then I multiply by Q0. So yeah, you have to watch out for everything here. That's the annoying factor. But, right, what is this? This is exactly the change of numeraire, right, kernel, like I said right here. Right, the change of numeraire kernel. So therefore, right, this is going to be equal to Q0 E tilde F of let's do one more thing. Let's factor the K out. right? And then this will become QF. So, right, let's pay attention. What we're saying is, right, we start out with a call option on the foreign exchange rate. We strike K. What do we end up with? We end up with a put option. We strike 1 over K on the other exchange rate. Okay, notice two things. So the strike here is K, the strike here is 1 over K. This is call, this is put, right? So call, put, strike K, strike 1 over K. This side is on share, this side is, and that's what this K is doing, K shares. Of course, right? What is this Q0 doing? Notice this Q0 makes a lot of sense, right? Without this Q0, in fact, it won't be correct. This Q0, remember, right? End up because I have to divide by Q0. Remember, I have to make this expectation 1. But right, this Q0 is financially very meaningful because it converts euro to dollar. It converts euro to dollar. So in fact, right, this Q0 is there out of necessity. So this is called the put call duality. Right? One share of a call, right? We strike K on one currency, right? Is equivalent to K shares of a put, right? We strike 1 over K on the other currency. Okay. Now, if you haven't thought too much about this, and I completely understand, right? No one really thinks about this before. Notice that this statement is a statement that makes sense independent of any model. All right. If you want, I don't know, you can do yuan to US dollars, whatever, right? You can do one call on a US dollar with 6 yuan, whatever, and then you can convert it back, and you'll see that it makes complete sense. So this statement actually is a statement that is true, should be true without any model. Like put call parity, right? But it's put call duality. So notice, right? Put call parity is a put and call on the same stock, right? On the same asset under the same unit. Right, put call duality is basically put and call on very different, right? Very different. Well, I mean similar, right? But very different exchange rate, right? One is one and one's the other, but you know, it's kind of had that taste, right? But it's independent of any model. But notice that we derive this fact by change of measure, by change of numeraire, right? Without change of numeraire, that's the point. Without change of numeraire, you will not be able to write this down, right? Notice how I convert right here using this, right? And reduce it down. So that's what I mean by what I said, right? When you operate under the right framework, things simplify greatly, all right? Notice that a mess like this just simplify to a different expectation on the put. Without that, right, you would not. But of course, right, the clue that is a mess here because you already convert to a different currency. So you're looking at it from a wrong angle. Okay. So I'll leave with it for you, right? I'll stop here, right? So I think the best way is to start out with these two applications. and try to contemplate and try to ask yourself, right, what is the change of measure, what is the change of numeraire, right? And then work your way back, right, to this theory, okay? And there's some hiccup here. I'll try to fix it. The hiccup is really because, you know, let me say, right, the hiccup is what you want to call a numeraire. All right. I hope you see that either one is fine. The point is that you have to divide by a martingale. You have to divide by a martingale. All right. So it doesn't really matter. Here I adopt the idea that this is a numeraire, but it might contrast what you might think of as numeraire in finance, because you like to think of currency as numeraire rather than money market as numeraire, right? So I don't know. I mean, there's good and bad, right, between the two frameworks. But that explains like this one. But I want you to see that exactly this is already a change of numeraire. Trust me on that. Okay. Yeah, and that's really it. I hope you. This is something you have to think about. All right, to get. I try my best here, but all right. So that's that. If you have any questions, I'll be happy to answer. If not, I'll see you on Monday. All right, for the last bit of lecture.